Hello, I'm meteorologist Rob Carlmark, and here we go again. Now, things have really changed in the Pacific, water temperature-wise, at the surface, in the one exact spot that we monitor very, very closely, the Niño 3.4 region. And what you need to know about that is that El Nino now is really gaining steam as a possibility. Not only is it coming, but it's very likely to be a strong one as well. So let's take you through everything from beginning to the end, because there's a lot of things lining up that could affect you in the months ahead and maybe even next winter. So this is what it looks like for the sea surface temperature anomaly. What does that mean? That means right at the top level, is it warmer or cooler than average? And then it tells you by how much. So this is in the middle of the Pacific. This is the region that we watch. But when you look at specifically that 3.4 region that I was talking about, it's kind of mixed right now. There's some areas that are warmer, some areas that are cooler. So it's almost even right now. There's basically barely any difference. If anything, it's slightly cooler. But that's where we watch at the moment. So we're in sort of a neutral zone right now. Looking off the coast of South America, look at all this. Warm water is coming to the surface. It is spreading out into that region. This is just the beginning of the trend. So we tend to see a big, huge finger of water essentially that goes all the way into that zone that's red. And that's when we start talking about that zone affecting the different weather patterns across the whole planet. And then we start to see things that we more or less have been charting over the years, so we can get some sort of ballpark idea about how those patterns may affect us. But there's other things happening at the same time, and this is what complicates an El Nino forecast. As of right now, we've got lots of warm water off the coast of Baja and even for most of California and the Pacific Northwest, a big bubble of warmer than normal water for a good chunk of the northern Pacific. So there's other things at play. I want to take you underneath the surface. So this is looking at buoys. They've got depth sensors here and thermometers that tell you what's going on in 3 dimensions. So we know about the top of the water here, which I just showed you. This is underneath. And then this is also from west to east. So this would be out toward Australia. This would be toward South America, just to give you some bearings. And these are little bubbles here called Kelvin waves. This is warmer than normal water that when the trade winds start to reverse, they are subsurface, meaning that they're moving in the other direction. They're moving from west to east underneath the surface, and then when they finally make it towards South America, then they hit the surface, and then this warm water starts to spread out. In other words, this is a train of warm water that's headed in our direction that will hit South America and then start to move out. And that's one of the key ingredients here, those Kelvin waves that start to ratchet up where we're going to end up later on. Now, this is where we are again. When you're below 0.5 degree centigrade for an extended period of time, we call that La Nina. That's where we were, just barely a weak La Nina for this last winter. And then this is where all the computer models are taking us. They're taking us not only into El Nino territory by the beginning of the summer, but way past that. So this is how you could see by how many degrees we're expected to be. 1 degree, 1.5, 2. Right in this zone. And this is really telling because we have not seen too many years where we get to this very strong, what we call a super El Nino status. And these years may trigger your memory. 82, 83, big water year for California, for all of California. 97, 98, big water year as well. Then the last time this came around, 2015, 2016, it did not pan out the same way. It was dry in Southern California, which we did not expect, and it was slightly wetter than normal for Northern California, just by a little bit. So this year did not pan out like the other two. So again, it's still an area of research. It's still something that we monitor and track, but it's not a sure thing. Now, in general, again, this is what happens. The trade winds start to subside. We tend to get that cool water replaced by warm water, and it starts to move out. So you get just a bunch of things that add up to warm water in the middle of the Pacific. And for us, this is what tends to happen during an El Nino year. We tend to see wetter than normal conditions in Southern California, warmer conditions and drier conditions for the Pacific Northwest. You know, we're somewhere in between, but for those big ones, we tend to see that wet pattern basically just take over the whole of California, even Southern Oregon. So that's what we look for. It's not a slam dunk. So again, just to summarize, it's going to be warm at the equator. It can alter the patterns. We have a long history of it usually doing that, but not every year. We're looking for wet Southern California and a dry Pacific Northwest. along with other things, and the strength does matter. So when you get to super El Nino status, which it looks like where we're going, it really does line up more often than not that it's going to be wetter than normal for most of California. Also, you see unusual things. You see strange warm water species of fish like whale sharks off the coast of San Diego. We saw that last time in 2015, 2016. Green sea turtles that ended up in the San Joaquin River. Again, these are strange things, but go back and look at it. Go research this stuff for yourself so you can see all the weird things we had leading up to that. Now, one thing that's a little bit more certain in this regards, and this is what probably concerns most of the planet at this point, we've got El Nino years, which are shaded in red, La Nina years shaded in blue. You see the overall temperature arc here going back to the 50s. Yes, we're in a period of warming right now, going past decades, but these El Nino years, notice how they're mostly above this line. It tends to, in a way, take us to a different level of warmth across the planet and then keep us there. So it's almost like an escalator. It notches up, but it keeps us moving in that direction. So of all the things that are statistically likely to happen, a big El Nino year tends to raise the temperature of the planet by a significant margin and then keep us there into the future.